All right, guys. So for our ANOVA lab quiz, essentially the difference between when you would run a t-test versus when you run an ANOVA is ANOVA is more appropriate for more complex sorts of data sets that have multiple independent variables or multiple levels for your independent variables. So a t-test is when you're interested in the difference of some mean dependent variable between two groups. ANOVA is if you have more groups than that, either because within a single independent variable, there's more than two levels within that IV, or there's multiple IVs when combined, creating more than two groups. So in the case of our prompt here, we are interested in some information about a sample of 30 undergraduates who are assigned to 3 levels of an amount of sleep variable, and then they were then quizzed, and so the DV was their quiz score. So critically here, we're set up for data where the ANOVA is appropriate. There's a single IV, the sleep IV, but it's got 3 levels within it. So if you look at your data set for this quiz and you look at the IV here, which is sleep, and you go over to the value part of the variable, this is where you define the levels for your categorical IVs, right? There's 3 different groups. So the first group are people that were assigned to sleep for 4 hours. The second group are those who were assigned 6 hours of sleep, and the third group 8 hours of sleep. So you can't run a t-test because there's more than 2 groups at play here. There's still, in this first part of the quiz, a single IV and a single DV. But what makes the ANOVA appropriate is that there are 3 groups instead of 2. So we're going to start by running a one-way ANOVA. A one-way ANOVA is when you have a single IV, but again, there's more than 2 groups. We're going to run an ANOVA to assess whether amount of sleep affects quiz scores. This is another key piece that makes the ANOVA appropriate. The dependent variable does need to be quantitative, so an interval or ratio scale. So something like your score on a quiz, that would be appropriate in terms of a DV that works for the ANOVA. So in trying to assess whether or not sleep impacts grade, here's how we're going to run our first ANOVA. You're going to go to compare means. You're going to go to one-way ANOVA. The DV goes into the dependent list box, and the IV goes into the factor box. In terms of things we want to do before we run the analysis, we can run descriptives. This will give us the actual means in the different groups. Just for fun, let's run a homogeneity of variance test too. And then here's our output. So since we selected in the options to get our descriptive statistics, we have the actual descriptives broken down by groups. So the mean level for the quiz DV for the people who got 4 hours of sleep, 6 hours of sleep, and 8 hours of sleep, as well as the standard deviation in each group. So the idea with the ANOVA is, again, are these 3 groups significantly different in terms of quiz scores? Just eyeballing the descriptives, there is a difference, right? The 4-hour group got a 2.3 on average, the 6-hour group got a 4.2, and the 8-hour group got a 5.1. So it does appear that the more sleep you get, the better you do on this quiz. But what the ANOVA does is it subjects those different means to the extent to which they rise to significance. So just eyeballing the means, yes, they're different, but are they significantly different? For that, we need to pop down to the ANOVA summary table that appears at the bottom. So I'm going to walk you through the bits of output. When you're writing your answers for this lab quiz, do not just screenshot this output here, because that does not tell me that you actually know what's what here in the ANOVA output. So to answer these questions, do go through and pull out the values that answer the question being prompted. So for the group means, right, you would pull those out of this descriptives box up here. So again, don't just screenshot that for me. I know you can screenshot. Make sure that you're showing me that you know how to pull out the numerical information that's being requested. So then for the actual output, you need to pull out of your ANOVA summary box. So what is your sum of squares between, sum of squares within, and sum of squares total? The ANOVA summary box is laid out very simply. So the sum of squares between groups, right, that's 40.867. Within is 38.6. Sum of squares total, 79.467. So those are your answers for your sum of squares. Degrees of freedom between and within, again, you just move across the ANOVA summary table. Your degrees of freedom between is 2. Degrees of freedom within is 27. Then the mean square, again, you just move over the ANOVA summary table. You've got your mean square between, your mean square within. If you didn't check out any of the lecture materials, either the slides or the audio for the ANOVA lectures yet, this is not going to make a ton of sense without that context. So you do still need to understand how exactly these values were derived. But in terms of the lab quiz, you can really just pull out these values being requested of you. So then the actual significance test in the context of an ANOVA. The ultimate statistical outcome, your obtained statistical value in your ANOVA, is what's called your F value or your F ratio. So just like a correlational analysis yields an obtained R value, and a t-test yields an obtained T statistic, an ANOVA yields an F statistic. So the value that you actually subject to significance testing is this F value. So your obtained F for this ANOVA is 14.293. The larger the F statistic, the more your groups are different, and the more likely it is that you have a significant F statistic or a significant ANOVA. Again, the greater an F statistic is, the larger the difference between your groups in terms of the DV. This appears to be a pretty large F statistic, and it is in fact significant. So the significance value is the value here in the sig column. So your significance value is less than 0.001. Again, remember, there's no such thing as a p-value that equals 0. It's just that when SPSS states that the significance value is 0.000, they are indicating that the p-value is less than 0.001. So this is a highly significant F statistic. What that means is that these groups are not all the same. Again, make sure that you review those ANOVA lecture materials because this is a pretty complex analysis. But as I stated in that lecture, the significant F statistic just tells you that there is at least one group here that is different. What it doesn't tell you is which group is different enough to be driving that ANOVA to significance. So eyeballing the means, they do all appear to be quite distinct from one another. But what your ANOVA F statistic doesn't tell you is whether or not 4 hours is significantly different from 6, or if 6 is significantly different from 8, or if 8 is significantly different from 4 and 6 combined. It just tells you that there is a difference present here. Okay, so that gets you through your ANOVA summary table. Now we're going to want to rerun our ANOVA with some follow-up tests. Again, make sure you review these lecture materials because the follow-up tests are sort of complicated to understand how you do them and why. But the basic idea of your follow-up tests is, like I said, a significant F value tells you that at least one of the groups is different, but it doesn't tell you which one is different. So that's what the follow-up tests are for. There's 2 basic strategies for running your follow-up tests. One is what's called a series of planned contrasts. This is if you predict that one of the groups is significantly different from the others. So if you think, for example, that a full 8 hours of sleep is significantly different from any amount of undersleep, so you predict that 8 hours of sleep is significantly different from 4 and 6 hours combined. Or you might predict that there's something special about only getting 4 hours of sleep that makes it significantly different from the other 2 combined. So first we're going to run our planned contrasts. This is kind of tricky to do, so just follow along with what I'm doing. Okay, so we've got our same one-way ANOVA. We just want to tack on some planned contrasts. So in order to do this, you're going to assign some contrast weights to the various sleep groups. To do that, you assign coefficients that tell SPSS, hey, compare the 8 hours of sleep group to the other two combined. So to do that, we need to create weights that put 4 and 6 hours together on one side of 0, and the 8 hours is on the other side of 0. So I'm just going to enter my coefficients in the order in which those levels are coded in SPSS. So since the 4-hour group is group 1, the first coefficient that I enter is going to be associated with that 4-hour group. The second coefficient is going to be associated with group 2, which is the 6-hour group. They're going to get a -1 as well. What this is doing is it's assigning negative weights to groups 4 and 6, such that they will be pooled together on the negative side of 0. Now, to compare groups 4 and 6 combined to the 8-hour group, I'm going to assign the last coefficient, which is going to be associated with group 3, the 8-hour group. I'm going to give them a +2. Some key factors in making this contrast system work is that all of your coefficients need to add up to 0, because the idea is you want to balance together the weight of the groups that you're wanting to combine and put them together on one side of 0. So these two coefficients are going to be pooling the 4-hour and the 6-hour group together on the negative side of 0, and then this 2 being on the other side of 0 is going to be contrasting the 8-hour group to the 6 and 4-hour groups combined. Okay, so don't do anything yet. You can actually run multiple contrasts in the same analysis. So if you just click next, this enables you to run a second contrast. So we're going to do the same thing, but we're going to switch up what we're comparing to what. So for your second contrast, compare the 4-hour group to the other two. So assign the 4-hour group a coefficient of 2 and both the 6 and 8-hour coefficients of -1. So again, you enter the coefficients in the order in which the groups are coded. So since the 4-hour group is group 1, we're going to put that coefficient in first. Now that we're pooling the 6-hour group together with the 8-hour group, we're going to give the 6-hour group, which is the second group, a -1, and the 8 a -1 as well. So that's your second contrast. Again, I know contrasts are really hard to conceptualize, so do make sure that you review those lecture materials, but in order to do this properly for the lab quiz, just make sure you're following along and doing exactly what I'm doing. Okay, so now we've got our contrasts programmed in and we can hit OK again. So the newly run ANOVA still has the results of our one-way test. That's the same. That doesn't change. We still have a significant F value overall. What the contrasts add on are those comparisons that we planned for. So in this contrast coefficient box, we can review that the contrast coefficients were properly entered. So recall that I said the 4-hour group in the first contrast got a -1, and that 6 got a -1, and 8 hours got 2. And the second contrast was comparing the 4-hour group to the other two combined. So you can verify that you entered your coefficients correctly there. And then the results of the contrast tests are down here. So we're going to assume equal variances. If you tagged on that homogeneity of variance test to the one-way ANOVA we did first, you'd be able to verify that the variances are roughly equal in my different sleep groups. And so we're going to use the values up here in assumption of equal variances in the different levels of our sleep IV. So then the actual results of the contrasts, they yield a t-value because we're actually creating two groups here, right? We're pooling together the 4 and 6-hour group to be one single group, and we're comparing it to the 8-hour group. So that's why your contrast is now a t-value instead of an f value. So then the significance for each contrast is over here in the sig two-tailed column. So we can evaluate whether or not our first contrast was significant. So recall that that contrasts 8 hours of sleep from 4 and 6 combined. So that first contrast is significant. Again, P is less than 0.001. What this tells us is that the 8-hour group is special and distinct from the 4 and 6-hour group combined. So there is something unique about getting 8 hours of sleep. The second contrast, recall that that contrasts 4 hours of sleep to 6 and 8 combined. Again, we've got our T statistic, negative 5.075. That means that the 4-hour group was even more distinct from the other two combined, but it's still highly significant. Again, what this tells us is that when combining 6 and 8 hours of sleep, the 4-hour group is distinct from those two groups combined. So both of these contrasts are significant. So what the planned contrasts let you achieve are basically planned in advance comparisons. It's slightly easier to achieve significance if you're using this planned contrast approach, because basically you're saying you have a prediction in advance of which group you think is going to be different. Now, if you don't have reason to suspect that one of the groups is special and unique, sorry, Jay's barking, Chris must be home, I hope you can still hear me. The other kind of approach for a follow-up test is going to be what we call a post hoc comparisons. So this is where, as opposed to planning a contrast in advance, you kind of just want to throw spaghetti at the wall and say, I think that all of the groups may be different from one another. I don't think that 8 hours is distinct from 4 and 6. I think all 3 of them are different. So I want to compare every possible combination of these groups together. So here's how you do that post hoc test where you don't plan any comparisons in advance. You're going to go back to one-way ANOVA. You can get rid of the contrasts if you want. You don't have to. It'll just reappear in your output if you don't go into those contrasts and reset or delete them. So for these post hoc comparisons, there's lots of different options. Honestly, a lot of them are basically similar. They just give you slightly distinct kinds of output, but they essentially do the same thing, where they're going to compare all possible combinations of these levels. I like Fisher's least significant difference. That's the one I've always used. Bonferroni is a fun word to say, so you can do that one too if you want. But for this quiz, let's just do a Fisher's LSD test. Rerun your ANOVA. Again, the descriptives never change no matter what follow-up test you do. The means are the means. The F statistic doesn't change, right? The overall ANOVA tells us that the groups are different. But now what the post hoc test does in comparison with the planned contrasts is it compares each combination of groups with each other. So is 4 different from 6? You evaluate that by looking at the significance level over here. Yes, when just comparing 4 hours to 6 hours, there is a significant difference. Then in interpreting it, you seriously just go back up to the means and you say, okay, 4 and 6 are significantly different from one another in that people who got 6 hours of sleep performed better on the quiz. Is 4 different from 8? Yes, that difference is even more significant. Okay, the difference between 4 hours of sleep and 8 hours of sleep is P less than 0.001. Again, indicating that people who got 8 hours of sleep did better on the quiz than people who only got 4 hours. This output is a little bit like a correlation matrix in that it's comparing everything to itself. So there's redundant values in here. So up here, you compare 4 hours to 6 hours and 4 hours to 8 hours. You can additionally contrast 6 hours to 4 hours down here, but it's the exact same information as comparing 4 to 6. So you only need to report your LSD tests for each possible combination. So 4 to 6, 4 to 8, and then 6 to 8. This one, on the other hand, you can find that value here in comparing 6 to 8 and down here in 8 to 6. It's just the same. You don't need to reiterate your redundant analysis. That comparison is not significant at p.104. So the quiz score is not significantly different between the 6 and 8 hour group. So again, looking up at the means, right? People who got 8 hours of sleep performed less than a point better on the quiz than the 6 hour group. And what that comparison tells you is that that particular difference of 6 hours to 8 hours is not significantly different. So it's a slight distinction from the planned contrast up here, where you compare 4 and 6 combined to 8. What this does is it tells you that when only considering 6 versus 8, that difference is not significant. So the choice of planned comparisons versus, or planned contrast versus this post hoc test of multiple comparisons, it's really just what your prediction was in advance. Either approach might be appropriate. It just depends on if you initially had an idea that one of the groups was going to be significantly different from the others. Okay, so that'll do it for our first one-way. We're going to do a quick two-way ANOVA, but there's really only one subsequent analysis we have to do here. A two-way ANOVA, in comparison to a one-way ANOVA, is when you have two independent variables, and you want to see how they interact to impact the dependent variable. So within the data set, I had this second IV of class year. Now the way it's coded in the data set, you can check here in values, is just splitting people into underclassmen and upperclassmen. So just splitting people into two groups. So this first question is conceptual. Let's say you want to evaluate the main effect of year on score without taking sleep into account at all. Why would a one-way ANOVA not be the ideal analysis for investigating whether upperclassmen or underclassmen performed better on the quiz? Well, that's because there's only two groups in that IV. If you were just looking at that underclassmen versus upperclassmen on their score on the quiz, you could just run an independent samples t-test. If you were to run an ANOVA on just the effect of that year variable on quiz scores, it will give you an F statistic, but it would be literally identical to the T statistic that you'd run. You might as well just run a t-test, because in this context, it is going to achieve the same thing, but the t-test is specifically appropriate for when you are comparing mean outcomes between two groups. So we're not even going to bother running an ANOVA to look at the effect of the year IV on quiz, because that's more what a t-test would be used for. But then lastly, we're going to look at the interaction between sleep and year. And we're going to pull out the P and F value. And we're going to see if there's any interaction between sleep and class year on quiz score. So here's how you do that. You're actually going to go to General Linear Model. You're going to go to Univariate. You might be confused why a two-way ANOVA is going to be a univariate ANOVA. Univariate ANOVA in this SPSS analysis just refers to the amount of DVs we'll be assessing. So univariate indicates that it's an ANOVA with a single outcome. If you ever want to run ANOVAs on multiple DVs at the same time, you can use this multivariate option. But since our quiz outcome is our only dependent variable, we're just going to select univariate ANOVA. So you're going to put sleep and year here in the fixed factor box, and you're going to put your DV, the score, your quiz score, here in dependent variable. Again, you can elect for descriptive statistics if you want, so that you actually get the means broken down by sleep and year. And then you can run that analysis. Okay, so like I said, it'll give you descriptives for all combinations of your IVs. So since there's 3 levels to the sleep IV and 2 levels for the year IV, you multiply the number of levels together to get the total number of groups or cells when combining both of your IVs, right? So some of the underclassmen got 4 hours and some of the upperclassmen got 4 hours, likewise for 6 hours, likewise for 8 hours. So there's means for all 6 of those various groups. So then what the actual ANOVA tells you is whether or not sleep and year interact to alter quiz score. So is there something unique about upperclassmen who get 8 hours of sleep where they do the best on the quiz? Now, in order to evaluate that, you go to, in this tested between subjects effects, the row where it says sleep by year. This is our interaction term. So there's a unique F statistic for the interaction that tells you whether or not the interaction is significant, right? There's a significant main effect of sleep. We already knew that because we ran the one-way ANOVA, so that F statistic is significant. But specifically, the interaction term is what tells us whether or not sleep and year interact to do something unique to quiz score. Again, the interaction would be about the two IVs combining to do something unique. So do people who are upperclassmen who only got 4 hours of sleep do the worst? That would be the two IVs combined to have a unique outcome. The F statistic, though, is non-significant. What that tells us is that sleep and year combined don't do something unique to quiz scores. There's main effects, right? There's a main effect of sleep. There's a marginal main effect of class year, but that's not significant either. But crucially for this question, the interaction is non-significant. So what that tells you, again, is that year and sleep do not interact to uniquely shape quiz score. All right, so that's everything you need for the ANOVA quiz. It's a bit of a tricky one. If you have all those analyses, you should be able to answer the questions. But if anything was confusing or appeared out of context, definitely review those ANOVA lecture materials because it is probably the most advanced analysis we're going to do this semester. So it is tricky. So make sure that you're really following along with all those instructional materials closely to make sure that you understand what the ANOVA actually accomplishes and how to do it. But that'll do it for my piece on this lab quiz. At this point, I'll cease the recording and take any questions that you guys may have.